Today we're looking at solving linear systems by graphing. So a system of linear equations, or simply a linear system, consists of two or more linear equations in the same variable. A solution of a system of linear equations that's spelled wrong, two variables, is an ordered pair that satisfies each equation in the system. So a linear system that has exactly one solution is called a consistent independent system, because the lines are distinct, are independent, and intersecting. Two things I would like you to add on is we're going to talk about consistent dependent and inconsistent. Okay, and I'm just going to draw a picture next to each of these. So a consistent independent, when you look at it, will look like an X. Okay, it has one solution, it crosses at one point. Consistent dependent is two lines, hopefully more straight than mine, that overlap. And then inconsistent is two parallel lines. What we're really looking at today is ones that will intersect. But sometimes you might get a solution where they don't intersect. That's no solution. That looks like two parallel lines. Okay? So if you get no solution, you know that it looks like two parallel lines. If you just get an ordered pair that'll be set up like that, that has one solution where it intersects. And if you get infinite number solutions, it will look like A equals A, where everything is exactly the same. So first we're going to look at a graph. And what I mean by consistent independent, where you have two lines that have a solution, we're going to look right here. See, we have two lines. They're both in y equals mx plus b. And they cross at a single point right here at 2, 4. Remember, we list the x first, the y second. And we can see that they cross at one point. We would label this one as consistent, independent. Okay, so this is just like we did before. They're in y equals mx plus b. They're both graphed, and they cross at a point, which is the solution where both of them work. Okay, if we move on to two equations, now we're going to graph these. Remember, m is our slope, b is our y-intercept. This should all be review, and they're set up in y equals mx plus b. If we look at our first line, which I'm going to do in blue, we graph the b, the y-intercept first, which in this case would be -1. We then follow the slope. The slope is m, which is the number in front of the x. If there isn't one, it's 1 over 1. So we go up 1 over 1, up 1 over 1. We're going to do that all the way up. Or down 1 over 1, down 1 over 1. We're just going to basically continue the graph. So we've got this nice line here in blue. The next one I'm going to do in red. We've got, and I'm going to just label it for this one so you know what I mean, b equals -3, m equals 2. So where am I going to start? -3. And then it's up 2 over 1, up 2 over 1, up 2 over 1, or down 2 over 1. And we get this nice straight line, and we can see that they intersect. Now my intersection is going to be 2, 1. And this is a consistent independent graph. Okay. So we're going to look at one more. And now these are not in slope-intercept form, our two graphs. We've got y equal 3x, plus y equals -2. And we've got x plus y equals 2. So we have to get both of these in slope-intercept form. So to do that, I'm going to subtract 3x from both sides. And I'm going to get y equals negative 3x minus 2. Now for here, my y-intercept, my b, is negative 2, and my slope is negative 3. So I'm going to graph this one in black. I put my first dot at negative 2, and then I go down 3 over 1, or up 3 over negative 1, up 3 over negative 1, and here's my nice graph. For the next one, I'm going to do this in red. I'm going to subtract x from both sides. And I get y equals negative x plus 2. My y-intercept, my b, is 2, and my slope is negative 1 over 1. So I put a dot at 2, and then I'm going to go down 1 over 1, down 1 over 1, all the way down. And then I'm going to go up 1 over negative 1, up 1 over negative 1, up 1 over negative 1, all the way up. And I can see that they cross at negative 2, 4. Remember to put the x value first, the y value second. And this is my solution to my problems, where the two intersect. Okay? We think, I'm going to mention one more thing about consistent independent, consistent dependent, and inconsistent. We think of consistent independent as an x. Or like an x, like you're crossing x marks the spot. That has an answer. One answer. We think of consistent dependent as two overlapping lines. I think of it as a genie. This has all solutions. Everything that you do, it works. And if we look at inconsistent, we've got two parallel lines, or I think of it as a touchdown, and this has no solution.